All right, this is the snow day video for Algebra 1, Unit 6, Day 12. Take a moment, pause the video, and work on your DMR 21. And when you're ready, play the video, and let's check your answers. All right, for number 1, we're asked to evaluate f of x when x is negative 5. So I'm going to write f of negative 5, which stands for plugging in a negative 5 for all your x's. So this would be negative 2 times negative 5 squared minus 3 times negative 5 minus 8. F of negative 5 now, as we do some PEMDAS, I'm going to do my exponents first. So this would be negative 2 times 25. And then I'll go ahead and multiply the negative 3 times the negative 5. That'd be plus 15 minus 8. Take care of that last multiplication. F of negative 5 equals negative 50 plus 15 minus 8. And that equals negative 43. All right, number 2 says solve using substitution. So in order to do this, I think I'll take the top equation. I could do this a couple of ways, but I'll take the top equation and solve for y. So y equals 2x minus 9. And of course, since y equals 2x minus 9, that means in the other equation, wherever I see a y, I could put a 2x minus 9. So that's what I'll do. So down here in this other equation, it's x plus 3y equals 8. So I'm just going to replace that y with 2x minus 9. I'll do a distributive property with a 3 to give me x plus 6x minus 27 is equal to 8. And then I'll just solve, starting with simplification. So it would be 7x minus 27 equals 8. I'll add the 27 to both sides. I'll get 7x is equal to 35. Dividing by 7 gives me my x value, or x coordinate of x equals 5. Okay, then I also have to find the y coordinate, and I'll just use this to do that. Y equals 2x minus 9, so y would equal 2 times 5 minus 9. That's 10 minus 9, which of course is 1. So my answer for my system, my solution would be 5, 1. All right, number 3, solving a radical equation. My first step is to get the radical all by itself. And so I'm going to subtract 7 over. This gives me negative 3 times the square root of x minus 5 equals negative 3. Still working to get the radical by itself. I'll now divide by negative 3. So square root of x minus 5 is equal to 1. I'll now square both sides. This gives me x minus 5 equals 1, and I'll add the 5 over, and I will get x is equal to 6. And perhaps you remember, if you're working with radical equations, your first step is to work to solve, but then your second big step is to check your answer. So we're going to check x equals 6. All right, so you're going to plug it in. 7 minus 3 times the square root of 6 minus 5 equals 4. 6 minus 5 is, of course, is 1. Square root of 1 is 1. I think we can see this is going to work out. 7 minus 3 is indeed 4. So I would say my solution is x equals 6. All right, and then lastly, number 4. First thing I'm going to recognize is that squared means base times itself. And then I'll distribute the minus sign. Everything is going to get subtracted in this second polynomial. So minus 5x squared minus 3x plus 6. You can use a box. You can use a number of ways to do this, but I'll simplify this first multiplication. I get 49x squared minus 28x plus 4 minus 5x squared minus 3x plus 6. And my final step then will be to add my like terms. So those two are like, When I add those up, I get 44x squared. And those two are also like, so that would be minus 31x. And then lastly, the positive 4 and the positive 6 are like terms. Adding those, I get plus 10. All right, that is your DMR. Hopefully that went well for you. If you have any questions, I'd encourage you to go back, watch the video. I think the steps hopefully are shown pretty clear there. But if something doesn't make sense, certainly send me an email and let me know. All right, so we're going to continue on what we did yesterday, and that is to continue to consider how to best solve a quadratic equation. Remember your options, all the things that we've covered so far. Factoring, we're going to do that if the quadratic is factorable, perhaps. Square root property, we're going to do that if b is 0. Will be something that we might do, but that's probably going to be the least common thing that we use. Quadratic formula is something that always works, even if the quadratic is not factorable. So we'll use that quite a bit as well. Okay, so I encourage you to look at numbers 1, 2, and 3. I'll show those to you. So there's 1, there's 2, there's 3. Matches up with your notes packet. So I encourage you to go through and try all 3 of these. Think about what the best way to do it is. Feel free to pause the video and do that, and then play the video and we can check your solutions and see if it all hopefully makes sense. Okay, so first for number 1. The current form that it's in, I would say that there's only one squared quantity. It does not appear that there is a b. So I would say b is 0. I think probably our best method here is to use square roots. And your first step in using square roots is to get the squared quantity by itself. And if you look at this carefully, the squared quantity is already by itself. So that being the case, I'm going to square root both sides to get this going. So when I square root both sides, I get 4y minus 3 equals plus or minus 7. And then I'll get the y by itself. So I'd add 3 over. Be really careful with this. This will give us 4y equals 3 plus or minus 7. Keep in mind that plus or minus 7 is 2 different numbers. Divide both sides by 4. And I finally end up with y equals 3 plus or minus 7 over 4. This can be simplified. So 3 plus 7 over 4 is 10/4, which is 5 over 2, or 2.5. And then 3 minus 7 over 4 equals -4 over 4. I've got -1. So I've got 2 different answers, 5/2 or -1. Should both be solutions for this equation. All right, number 2. For this one, the b is pretty clearly not 0. You can see it over there. Looks like it involves a 9. But you can also see that this is not in standard form. So I'm going to put it in standard form by adding 9x to both sides. When I do that, I get x squared plus 9x plus 1 equals 0. Pretty sure that this does not factor. I don't see any numbers that multiply to be 1 and add to be 9. And so I think I'm going to have to use the quadratic formula here. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so I want to identify each of these. So my a is right here, and it's not very obvious because it does not appear to be a number there, so a is 1. Right here, we could say that b is 9, and then lastly over here we could say that c is 1. Once I've got those identified, I am just going to plug in, and we'll see where this goes. So x equals -b, that would be -9. Plus or minus the square root of b squared, that would be 9 squared. minus 4 times a, which is 1, times c, which is 1, all over 2a. Well, a is just 1, so that's just going to end up being a 2 down there. Okay, so I'm in pretty good shape here. I just need to follow some PEMDAS and see where this goes. So negative 9 plus or minus. 9 squared is 81. 81 minus 4. And then all divided by 2. All right, so to finish this one off, need to recognize that 81 minus 4 is 77. All divided by 2. And I need to simplify this, but I think 77 is just 7 times 11. And, of course, those two numbers are both prime. There's no pairs. So I don't think that 77 simplifies. The square root of 77 simplifies at all. So I'm going to just leave it as is. This would be my final, my two solutions for this equation. All right, finally number 3. Once again, we can see that for number 3, the b is not 0. Certainly involves a 2. But this is not in standard form currently. So I'm going to put it in standard form. I will do that by subtracting the 2x over and subtracting the 3 over. So I get 3x squared minus 2x minus 3 equals 0. And again, does this factor? I don't know. Let's try it out. There certainly is no common factor. There's no greatest common factor here. And so, maybe we try the boxes and just see 3x squared would go there, minus 3 would go there. My AC would be negative 9. And that's where I think we run into kind of a dead end, because I don't think any of those pairs of factors are going to add up to be negative 2. So I think we're going to have to use the quadratic formula again, which is fine. I'll see how this works out. In order to use the quadratic formula, I need to identify my a, b, and c. So I would say that a is 3, b is negative 2, and c is negative 3. Once I've identified those, I just need to plug those into the quadratic formula. So here we go. X equals negative b. That would be negative 2. Plus or minus the square root of b squared. So it'd be negative 2 squared. Minus 4 times a times c. Like so. All divided by 2a. So x equals positive 2, because a negative times a negative is a positive. And once again, a negative times a negative is a positive, so it'd be square root of 4 minus, and this would be negative 36. All divided by 6. And then, of course, that's really 4 plus 36, so I'm getting 2 plus or minus the square root of 40 all over 6. This is where this is a little different than the previous one, because you probably recognize that the square root of 40 can be simplified using your prime factors. So this would go to x equals 2 plus or minus 2 square roots of 10 all divided by 6. And lastly, you probably can recognize that there's a common factor of 2 in all the terms. So what I can do is I can cancel this and this with this, giving me a final answer of x equals 1 plus or minus 1 root 10 all divided by 3. That would be my most simple answer, my most simple solutions for this particular question. Okay, so I hope those went well for you. And again, if something doesn't make sense, you're certainly welcome to ask, and I'll be happy to help you out. So hope you're having a great snow day, and I look forward to seeing you soon.